Hello, everybody. My name is Adrian, and together with Travis, we will talk about how can you protect 50 billion devices and keep 80 billion people safe in 2020.
Yeah. Maybe just before we start, how many of you have a connected TV? How many of you have a wearable? How many of you have a modern BMW or a Mercedes with a navigation system that connects to the internet? A couple. Yeah. We're just starting. It's growing, and it's growing really, really fast. And there's obviously a bunch of things we want to talk about, and I'm going to let the head of our IoT labs start it.
Yeah. Before we start, I want to ask another question. How many of you have played with the security and privacy settings on these devices?
One, two.
One. Today we'll touch the topic about privacy and security and how these two components are very important for the connected products and what can go wrong in case we don't use them properly. I would like to be the devil advocate here and tell you that if you want to create a 100% secure connected device, it will not be economically feasible. And why is that? Let's say I want to buy a new appliance for my home, and I will choose a connected toaster. Usually, I don't want to pay more than $200 on this product, but I want to use the product for at least 10 years. When the manufacturer released this product to the market, maybe it was 100% safe. But in order to keep it safe for the whole lifetime of the product, the manufacturer needs to use teams which handles the security and connectivity. They need to have security researchers. They need to push security updates. They need to keep all the auto-update infrastructure in place. And when you think that the manufacturers work with a very low margin, all of this adds up, and finally the company will burn money. Okay, you can choose a different business model, but at the end, all of those business models will get to the same end. Usually, you as a manufacturer will be left with choosing two of these, and I bet that almost all manufacturers will choose between cheap and smart when selling a product. It's very important to think about security. And security in a software-related product is completely different than a build, ship, and forget product. Security is iterative, and vulnerabilities are found daily. And if we don't think about security, our future can look like this. When maybe the toaster will say, I will burn your bread if you don't pay me some dough. Or the thermostat will ask you for money if you want to start the heating. Or the fridge will not open the door until you pay some money to it.
And while this might sound ridiculous, we actually see it happening, right? WannaCry, the most recent outbreak of ransomware, it's an extremely productive business model. People will pay a little bit of money just for the convenience of getting the hassle away. So if the threshold, even those little things disturbing don't sound that great, when you're dependent upon them, your breakfast in the morning, you're opening your door of your house, your lighting system, to pay 20 euros to somebody to get it free again is actually very feasible. But there's other challenges as well.
Yeah, so we've seen last week the biggest ransomware attack in history. And this ransomware attack took down the healthcare system from UK. And okay, it infected only Windows computers, but at the same time, these computers are connected to X-ray machines, patient databases, CT scanners. So you see that where things can go wrong.
And that's what actually makes the whole system quite complex, because you have service portals, control systems, and devices in your house, and any one of those could be the weak link where something could happen.
Also, last year we had different examples of IP cameras being hijacked by hackers and started spying on kids and even talk with them. Or last year in September, the biggest DDoS attack happened, and it was orchestrated only by IP cameras. And this attack took down the DNS infrastructure. Also, Twitter and Spotify went down.
Right. And so here we have a situation where it's not about me, it's not about my information, it's not about my assets, but it's actually using something that I have in my infrastructure to attack something else. So while my personal interests potentially are not harmed by this type of an attack, nevertheless, the whole internet is. And so these are things that we have to consider as well. So, you know, as I mentioned also in the presentation outdoors, this evolution is going really quick. We went from laptops to smartphones, and the amount of devices coming online, whether it's the Echoes or the Apple and Google voice control devices, whether it's the home automation systems and such, the evolution, and of course, at the same time, the amount of possibilities where data is being stored, devices are connected, data is being transported, value is being created, is exploding exponentially, which of course is exactly the place where the bad guys want to go, right? They want money, they want to earn money, and they want to do it in a lazy way, which means just abuse the system and try to monetize it.
And also there are some estimation that will say that by 2020, we will be surrounded by more than 50 billion devices. I think Cisco gave this estimation. And this is one somewhere in the middle as an estimation. And also by 2020, you will see that the data generated in 1 second will be the same amount of data that was generated between 2014 and 2015. Yeah. And 90% of this data will be generated by sensors surrounding us.
And if you look at the threat curve that we had on the standard operating systems, like Windows and Mac and Android and iOS, many of the companies wish that their revenue curve looked as steep. It is exploding. And so through all these data points, whether it's 50 billion, 20 billion, or 80 billion, whatever the forecast of your preference says, it's enough. There's enough issues going to be occurring, and there's enough threat that something needs to be done.
Yeah, seeing this exponential growth of these devices, we also see an exponential growth of the attack vectors that put our data, privacy, and security at risk. And when everything will be connected to something else, will be a link to something else, security will be strongest as its weakest link. In order to understand how we can protect a connected device, we need to understand how this device is made and what are the attack vectors, which then will create the attack surfaces. And the goal is to minimize as much as we can the attack surface. If we look at the connected appliance, we'll see all these 5 layers. The embedded device, which represents all the memory, CPU, flash storage. We see the software layer, which makes the device work. The communication protocol, this is the communication between the device and the cloud. The cloud itself, which exposes some web services, it integrates some third-party apps. And then we have the connectivity part, which is maybe the application part, which is the way you interact and connect with the device.
I mean, one thing to recognize the difference, a laptop computer or an Android telephone, you're much more able as a user to go in and to change, configure, or we as a software vendor to install and do something. In many of these devices, they're closed. We can't install software. We can't, as users, really interface. And the interfaces that they're quite complicated and technical, and most users, like the ones that didn't raise their hand about looking at the security settings of their TV, it's too much. They don't know even how to deal with the information that would be available to them.
And also on this type of devices, we're talking about low-power devices with low processing power, because most of the times we're talking about battery-powered devices, and it's very hard to go and add a traditional security software or system on it. And when we look at these 5 layers, we also can see what kind of threats we can have. One is device control hijacking, which means that you can take control of somebody's device and do whatever you want with it. It's like I have access to your lighting system, and I can turn on and off the light whenever I want. Another attack vector is the reprogramming part. So you have a device which maybe a watch, a smartwatch, which shows you the time, monitors your steps, and if I can add different software on it, I can make it do something else. If I want to get the data that is flowing between the device and the cloud, and if there's no protection between in the communication layer, I can put myself in the middle of the communication and get the data that the device is sending and what the cloud is sending back to the device. Also, I can block the device. I can play some replay attacks, which means that maybe I turned on and off the light from my home. Somebody spied on this message, and then it just plays it back whenever I'm not at home. I can do some cloning on the device and also data theft, which I think it's very important.
Yeah, and I guess what's really important about the whole aspect of the industry is because the manufacturers of these new devices want to solve a need or address a new market, functionality is trumping security. Security hits when the reputation starts to get hurt because someone is using it for the wrong purpose. But at the foremost, in the forefront of all their thoughts is we want to do things to make the world faster, better, cheaper, and therefore functionality is pushed out. And those things can happen.
So when we want to design a new connected product, it's important to think that we need security from the beginning. Sometimes it's very hard or almost impossible to retrofit security on an existing device. And that's why we have to take security into consideration from the beginning. And also security will play a very important part in designing the product. It also can affect the features of the device, but also the cost of the device, because security is an iterative thing, and the cost go up during the development life cycle.
Of course, as a vendor, and we'll talk about it, we need to reverse and be able to do this from the far. But from the vendors, it's important because what most vendors forget is the more confidence users have about using my product or service, the faster I will be successful. And so very often, the piece that they miss in their mental state of mind is security gives confidence. Confidence means success for my service or application or device.
The focus is not to prevent all attacks, because this is impossible. The focus is to prevent the dangerous attacks. We can have like the annoying attacks, the trivial attacks, where somebody gain access to the device. It can unplug it, it can smash it with a hammer, and this is it's hard to prevent as a manufacturer. But there are other type of attacks where you can gain access to one device, and from that device you can gain access to other devices without having physical access to those. And the difference between these two attacks is the scale. Because one is one device, or going to the whole chain of the device of the same time from a manufacturer.
Right. In security, it's always a balance between how much am I willing to invest versus what do I see as my possible risk scenarios. And so, as Adi mentioned, perfect security doesn't exist, which means I need to calculate and try to break down where is my biggest threat possible that is mass, easy to do, that will be copied and exploited, versus potentially ones that cost high investment to even be able to break into.
Some basics in security. First is don't build a product which uses default passwords like admin 1234 or demo. Make the user set a strong password. Don't let the user choose a simple password. This is like the obvious things that you can do in order to protect a device.
Yeah, it's actually quite amazing. If any of you, who here is a customer of Kabel Deutschland in Germany for your internet connectivity, if you order the Fritz router boxes from them and you get them at your home, the default password is password. Your router for the internet, for all of your devices, for your entire home, has a default password by the delivery called password. I mean, these are unacceptable behaviors, but a user doesn't know. A user is just happy that their devices are working and everything is connected and they're streaming. But what does it actually mean that my default password is password?
And also, usually the manufacturers want the user to use the product as fast as they can. And most of the manufacturers are appliance manufacturers don't have experience with software. And for them, they just want to get the product fast on the market, and they don't think about the user experience, and that's why they usually go with the simplest way of configuring the product and don't create a complex application which helps the user set up the product. If we go on, if we start with security from the base layer, we have to think about how we can protect the embedded part. It's important to disable all the debug interfaces. So nobody can connect to the circuit board and see what the device is doing. You have to make sure that you don't use any unprotected file system. First, you have to see if you really need one, because most of the small devices don't even need an operating system, a file system. Make sure that the information that is stored on that device, it's encrypted. And also make sure that each device, it's unique and has some unique identifiers. Of course, this will mean more expenses during the production of the device.
Right. And of course, over time, we as a vendor who sees all these devices are collecting these informations. We know what manufacturers have done what we have to be careful for, and how we can help the user prevent against it. But the most important part of all of this is it's usually something to do with firmware. That's the software that's actually on the device. And if you go look statistically, and we see it already even in the Windows operating system world or the Android or the iOS world, it's amazing how many applications and services are up or out of date. So despite the whole industry already having this many years of experience on those basic smart devices, we can't even keep the systems up to date, which resolve threats. WannaCry would not have been a threat had everyone had the most recent update. This is an issue that we're dealing with. Yeah. And so we as a vendor need to bridge that gap.
Yeah. And as Travis said, if we go further in the firmware, in the software level, it's important to protect the software that you added on that device. You can sign it and make sure that when the device boots up, you verify that the software that will run is the software that was intended to run. And also you have to make sure that nobody managed to add into the memory some piece of code and which will be run by the device itself. You usually have to make sure that the device is up to date. The best way, so from our experience, we've seen that the users don't update their system. And if you let the user to upgrade its own device, he will not do it. Because if you have 10 light bulbs at home, you will not upgrade each one of them. But if you have a system to automatically push the updates, and then you make sure that the device is secure. Also, you must prevent the cases where maybe a faulty update will ruin the device. It's important to have a fail-safe and always roll back to an existing state. If we move up in those 5 layers, we will see that the link between the device and the cloud is very important. You have to encrypt the data that is passing through that connection. And we've seen manufacturers that they are going to plain connection, which is not good because all your data can be stolen. We see manufacturers which are using their own protocol of communication, but they are using this protocol over an open channel. And this is not a very good approach, because it's better to use with something that is tried and tested. Don't try to reinvent the wheel. Go with the existing encryption protocols. Go with the public-private keys model. And even if a manufacturer will say, okay, my device is so small that I cannot run a private public key algorithm on it, they are wrong, because now more and more libraries appeared on the market, which helps you embed them in very small power devices.
And this is actually the wonderful part about the internet, right? There is open source. Open source is there for a reason, and it's open source is great because it gives you the security that it's been looked at by thousands or millions of people. So we really have a plea to the vendors to go for the standards and not try to create their own.
When a manufacturer starts to create a new connected product, usually, if he doesn't have any experience in building all the communication part of the device, he will go to a third party. And the third party will say, okay, I have this chip which offers you Wi-Fi connectivity, Bluetooth connectivity, but on top of it, I have security, which means that you can run some encryption algorithm directly on the chip. What's important for a manufacturer is to know that even if the chip offers those libraries or those functionalities, you need to make sure that you're using those properly. The libraries that they offer you are up to date. They pass some a list of tests to see if they are vulnerable to some exploits. And also have to make sure that whatever you get, you implement it properly, because the chip manufacturers make money from selling those devices. How you can make sure that they are always keeping up to date their software that they are providing with the chip itself.
And what I can guarantee what will happen, because we've seen it already so many years, and history does teach us this lesson, is that security, when it's just a check mark, as Adi just gave examples for from the chip manufacturers, it means there is no security. And when there is no security, one day something will happen. At the end of the day, that brand that's out there and that occurrence that happened, it's not the occurrence of the chip manufacturer, it's the brand of the vendor who trusted the chip manufacturer's security.
There was a study made by the Online Trust Alliance, which stated that 100% of all the attacks that happened using connected devices could have been prevented just by following some very simple security best practices. And usually manufacturers just want to go fast in the market, and they will miss the security part of a device. We've presented you here some basic concepts on security, but these are for the new devices. What happens with the old devices? Can we retrofit security? And my answer here is yes. We at Avira have started a new project which will help protect the connected devices from attacks from outside, and also stop these devices to attack other sources from outside.
In the next 2 weeks, you'll see coming from Avira a piece of software that actually builds onto the existing infrastructure. Many companies are trying to attack the situation by adding hardware, and nobody's going to buy another 99 euro box and put it somewhere in the network. That their security consciousness is not working that way. We actually have a product that will sit on your existing infrastructure, be that your routers that your ISP gave you, be that systems or devices you already have in your network. And what it basically does is it uses machine learning, and through the knowledge that we get through the worldwide view of our existing user base, we're able to build those databases and know where those risks are that we outlined, so that we are able to change routes on your routers to prevent communication from occurring, signal firmware updates, potentially even execute firmware updates for the user, so that we take that whole security, or a large part of that security thinking and complexity, out of the user's hand and allow it to happen autonomously in the background, so that the user can do what they wanted to do originally. Watch videos, lock their house, turn on their lights, drive their car, surf the net, buy things, shop, do all sorts of things, but definitely not sit there every day and worry about their privacy or their security.
And also this solution is very important for those who are providing the network infrastructure, because in a DDoS attack, usually you are the one who's suffering, because your bandwidth would be used for something not useful for the users, and users will complain to you. And this solution will help you keep your pipes clean.
Right. So, any questions? If not, Adi and I are around. We appreciate the time, and thank you very much for listening.